FSK is the digital counterpart of the analog FM frequency modulation. Here the frequency of the carrier signal, sinusoidal carrier signal, is varied according to the binary input signal. So instead of FSK we should write it as binary FSK. We will discuss M-ary FSK later on if time permits. So again it is called keying or switching, as the carrier changes its frequency abruptly from whenever it receives a transition between 1 to 0 or 0 to logic 0 to logic 1. The FSK signal can be represented like, say, omega 1t for logic 1 and AC cos omega 2t for logic 0. Here this omega 1 means 2 pi f1, omega 2 equal to 2 pi f2. So to understand this FSK, let us take an example. So here we have consider this as F1 frequency, carrier 1, first carrier. So it is of, say, higher frequency like this. And we need another carrier, say carrier 2 with lower frequency. The same amplitude is AC. Say this one is the for the sake of simplicity, let us assume that integral relationship. So for 2 complete cycle, here we have, say, 1 complete cycle. Something like this. So if we have a given data, that data may be anything like 1 0 0 1 1 0, say. So the waveform of FSK signal will be like this. Logic 1 will be represented by this carrier. So within this bit period we have 2 carriers. Now we have logic 0, means this carrier. Then we have again logic 0, so this carrier. Then we have 1 means this carrier. Again we have 1, so high frequency carrier. Then we have 0 means low frequency carrier, like this. So for this data, the waveform will look like this: higher frequency, lower frequency, lower frequency, then higher frequency, lower frequency. So in this way, the waveform will change. Binary FSK signal. Now if we calculate the power spectral density, we are plotting one-sided. First of all, for one carrier we have this one. For other carrier so this one is F1, this one is F2. So we have two frequencies. One is this F1 is for logic 1, F2 is for logic 2. So this will be the waveform. So this frequency is F1 plus 1 by TB. This one is F1 minus 1 by TB, and so on, something like this. So the minimum bandwidth requirement is this. This is the minimum bandwidth requirement. So 4 by TB minimum is 4 by TB, that is 4 FB. So bandwidth requirement is higher compared to ASK or PSK. Actual bandwidth requirement will be much higher because this is the minimum difference between two signal carrier chosen, but actually they must be well separated, otherwise it will be difficult for us to detect it. Now the generation of FSK. Since FSK is a counterpart of FM in analog domain, we can use simple frequency modulator for generation of FSK signal as well. The only thing is that here we have the binary signal, but the data binary data in polar form. Another output we have carrier frequency. That may be generated within this system as well. Here we have the FSK. Now we will consider the detection of BFSK. Detection of BFSK. FSK can be demodulated with coherent or non-coherent technique. Both the technique may be used. So first consider the coherent technique. Coherent detection. For that, we have BFSK signal as input that will be divided into two parts. And we will use two product modulators or multiplier, and we need two locally generated carriers, omega 1 and omega 2. Omega 1 for logic 1 and omega 2 for logic 0. Next we have integrator, and the output of upper one is say L1, and that for lower is say L2. Next we have a comparator. Comparator will compare whether L1 greater than L2 or not. So based on that we will decide symbol 1 if L1 greater than L2 and symbol 0 if L1 less than L2. So this is how it works. Obviously it requires phase lock for both the carriers and bit synchronization for those integrators, but the performance of this system obviously is better compared to the non-coherent technique. Now we will discuss non-coherent technique, and this non-coherent technique is almost identical to ASK, but thing is that for ASK we have a single channel. Here we have two channels for both the carriers. So first the BFSK signal is divided into two parts. In upper part we have band pass filter at say F1 frequency. In lower part we have band pass filter at F2 frequency. That means this band pass filter will eliminate all the frequency component around F1, out of band signals around F1, and this one will eliminate all the out of band signals around F2. Then we have envelope detector, means rectifier low pass filter combination. Next we have sampler. So sampler will run with the help of bit synchronizer. Output of this sampler see L1, and this one is for say L2. So that will be compared with the help of a comparator. And if it is logic 1, then obviously some carrier will be there at frequency F1, so L1 will be finite value, will have some finite value, but at that moment L2 will have some lower value. So because of that we will select symbol 1 for L1 greater than L2. Similarly, when we will transmit 0, that means we will have a carrier at frequency close to F2, so L2 will have some finite value where L1 must be very small quantity. So we will, under this condition, we will select symbol 0 for the other condition. So this is how we can demodulate BFSK signal in non-coherent technique, and this we are using envelope detector type of thing, so it's very cheap compared to this one, the coherent technique. But performance wise, this coherent technique is much superior compared to this non-coherent technique. Now there are certain merits and demerits of this FSK. Like BFSK is relatively easy to implement. Its noise immunity is obviously better than ASK, as there is no change in amplitude, as we have seen that the waveform of the FSK, there is no change in the amplitude, and noise most of the time affect more on the amplitude. And since this FSK signal is not using amplitude as a carrier, amplitude as a parameter rather, so it is less affected by the noise. So it is much more immune to noise compared to ASK. But if you compare it with the PSK, obviously the performance of PSK is far better compared to FSK. The bandwidth requirement of FSK is comparatively high as per this BFSK, BPSK or BASK is concerned. So that's the one of the disadvantage of FSK signal.